for why does this wave occurs and how does it break spaghetti. And at the same time, they tried to make their own calculations on which is critical velocity for this breaking. Also, they measured critical stresses for both bending and buckling for the spaghetti, which is certainly a good point because we can speak about the mechanical properties of the spaghetti. The same as also reported team tried to change these mechanical properties of spaghetti, like freezing it, baking it. That's also a good point because this parameter is also very important. At the same time, we have seen some work on the experimental setup. It can release spaghetti at different angles. The reporter proved that they can neglect drag, also a good point because the height from which we drop spaghetti is certainly a more obvious value for us to consider to talk about than the velocity. Also, one of the biggest points, like the main point of the solution by the reporter was connection between critical velocity and critical angle. We have seen some equations and estimations which were then made an attempt of proving this with an experiment. Well, the attempt was rather successful, I must say, which was proving that this connection does really exist and it does really happen in the way reporter described. However, I must state that there are some negative points of the report. First, I have to say that only one way of breaking was considered. I have asked during my questions that reporter considered that the heating end of spaghetti wasn't moving during other bending occurring in the spaghetti. This is estimation, and well, I must say that I'm not agree with it yet. We will discuss it later. The same I must say that, in my opinion, not only bending wave can break spaghetti. However, this was for reporter up to choose which theory to work on. So I will ask my further question only on the reporter's theory. Also, I still can't understand this calculation of critical force. It's one of the main points of the whole report. However, I didn't understand what does it really mean, and also a big question is distribution of this force. Because I'm pretty sure that also, how it was mentioned in the reference by reporter, there is some certain point in which this force reaches its maximal value. It's not the end, it's not the beginning, and this is a very important question, in my opinion. Also, I must say that, in my opinion, these experiments have a rather low, how to say, I'm not sure about the results of these experiments because only not very big amount of measurements were done. And certainly we can say only about probability of breaking, in my opinion, because spaghetti is very difficult structure, organic matters. It's really difficult to say that it really has a certain velocity when it will break and it will won't. So we'll ask further question about the errors of measurements and how to decrease these errors if they still require decreasing, or maybe I will be proved that the errors really were low. So I think we should proceed to the discussion. First, let's start from the theory of breaking, which you showed to us. One of the interesting questions, I mean, is the spreading rate of the wave you described. Have you tried to estimate spreading rate?
The rate?
The speed of the wave which is going on your spaghetti.
Okay, I will have to calculate a little bit to have that. So the spaghetti we were using is approximately, it's actually 0.5 meters, and from the beginning of the touching to the end of when the wave touches it, it's about 4 to 5 frames. So let's take 5 frames, and this experiment is under 1200 frames per second.
Oh, okay.
So we could calculate from this. Do you want
and
to calculate?
You're calculating the velocity, the time which passes between when this end hits the floor and this end. However, I'm interested in the question because we could see in your videos that wave is going in front of the point which hit the floor. Can I be shown, maybe I will touch my laptop, and let me take a look at the video of breaking once again. Okay, we can, on this video we could see that the point where spaghetti breaks reaches the floor.
Yeah.
It's like some curvature which is going over spaghetti while it still hasn't reached the floor.
Yeah, it
And-
doesn't reach the floor.
And I am asking about the velocity of this curvature. How long is it coming to the part of spaghetti which hasn't reached the floor yet? Have you made such estimations?
The curvature? Can you explain your question?
Well, I mean that on the video we could see the picture of something like this. Spaghetti lies here, then we have something like this, and only this spaghetti goes.
Yes.
And I'm asking about this particular place.
Yes.
Is it going in some constant distance from the point which reached the floor, or is it going there, or what happens to this particular place? Because I think that breaking occurs there.
Yeah, it travels, and this is actually a wave, and we could consider what happens when this wave reaches this end is that this is a open end. So we know when a rope reaches an open end, it will reflect, and then it will duplicate. So that's why we see the bending increases at the end.
Okay, thank you for your answer. It's really made a lot of understanding of the question because the report hasn't mentioned it, but however we're explaining that bending increases when this wave reaches this end. Okay. Also, the question is, when spaghetti is falling on the floor, you're considering, as I understand, that angle is all the time the same. When it's like this on the end has reached this angle theta, and here it will be also angle theta. It doesn't changes during impact.
It doesn't change until it reaches the end. The wave reaches the end.
Well, okay. And also, still, you were saying that breaking occurs when this wave reaches the end. And I'm interested, is the wavelength, does wavelength depends on some parameters of the spaghetti?
Yes, it does. If the spaghetti was stiff, the wavelength would probably be longer. If it was soft, then it would be short.
Okay, and what about length of spaghetti?
The length of the spaghetti won't affect the wavelength. Also, the velocity and the contact angle will also affect the wavelength.
Okay, thank you. And for this question, still, when a wave reaches the end, it duplicates bending, as you said. And I'm interested, but still, spaghetti doesn't break exactly in this point.
No, it
Still,
doesn't.
it breaks in several parts, which means that wave also comes still here and here. Can you please explain me somehow, maybe briefly, still, what happens then to the wave? What does it do with spaghetti?
Okay, first, so when the wave reaches the end, right, another wave will be coming back towards the original wave. So what happens is that when the two waves combine together, and because it is an open end, an open wave with an open end, so what happens is that we can consider it as a wave coming back towards like this, right? So this part will be very high. So what happens is the highest point where the highest curvature doesn't occur at the end, but somewhere back down here. So what we need is the greatest curvature. So when part of the spaghetti reaches the greatest curvature, it will break off. And you want to say about the
And when you are saying about maximum curvature, I'm interested in how does it, has you, for example, try to estimate how are they connected maximum curvature with spaghetti ridges and this force, critical force, you're calculating?
We actually have the numbers for the critical force.
For critical force, yes, and for critical curvature.
Critical curvature, yes, we do. Just a second. Okay, this is the critical curvature of our spaghetti, and for the spaghetti that we use is a thick spaghetti, and it is baked, and the critical curvature, the radius of the critical curvature is 20 centimeters. Yeah.
Okay. By the way, very good to notice is that we can from here understand why does baked spaghetti break easier. Yeah, this is also an important point. And still, if you are talking about such thing as critical curvature, duplicating of wave, I assure that you still can consider that there is some constant force acting on spaghetti during impact, and that really this force is breaking spaghetti.
Yeah.
Because I'm not sure that when we work with this wave, we can say anything about some constant force acting on spaghetti. But you still state that there is constant force. Well, let me notice that I still disagree with respected reporter in this point of view, but unfortunately it requires a lot of discussion. I'm afraid we just can't came to one point of view here. So I'll proceed with other questions. Also, based on your theory, you mentioned what will happen if we will change such parameters as length of spaghetti. So as I understand, the main reason is that we change with length, we also change mass of spaghetti.
Yes.
This is the main way of changing all the results. And what will happen if we will have the same length of spaghetti, but we will change mass? There will be, for example, we will add some small weight, which will be neglectably small to the dimensions of spaghetti, but it will be still changing mass. We will see the same effect happening like a longer spaghetti, yes?
Oh, so if you change the mass?
Yes.
So
But without changing
the length.
length.
Yeah, if you change the mass and if you don't change the elasticity of the spaghetti, basically the average force will be increased. So what happens is that it will be easier to break.
Okay, but however, don't you think that this long spaghetti will have a different also curvature displacement? That for this spaghetti, for example, wavelength can be bigger, and for this reason, this curvature may be a lot bigger. Don't you think that it can happen?
Just by changing the mass?
No, by changing length.
Oh, by changing the length, you think?
Yes. Won't it affect curvature displacement?
Curvature
Yes.
displacement. Curvature displacement.
No, I mean, will it be curved? Will the sand be curved the same as the shorter spaghetti?
Oh no, what we've measured is the critical curvature. So basically what happens to a spaghetti that it is not a semicircle, so the curvature is not identical. It's something that looks like this, and there is a point where it has a maximum curvature. So what we measured is the curvature radii of this point. Yeah.
Okay. And further asking on parameters, I want to ask about such parameter as diameter of your spaghetti. Has you tried to somehow change it, and what will it affect if it changed?
Of course. Okay, I'll just say it.
Yes.
First of all, the small spaghetti will be harder to break because as we can see, the curvature is actually smaller. The critical curvature is smaller. And what do you want to discuss about the mechanism?
No, I understand.
Yeah,
the mechanism of this, I think there will be no discussion about it. But I'm wondering, because you're still changing the mass with changing diameter.
Yes.
And for example, if you make a very thick spaghetti, you're increasing mass of it. So it is harder to break because it requires bigger curvature, but at the same time you have a bigger mass and bigger force, which you are calculating.
Yes.
So what will be the winning mechanism? What pays greater contribution? The changes of mass or changes of critical curvature?
Changes of critical curvature.
Okay, thanks for your answering. So, however, I want to summarize what we have just talked about. We have talked about some parameters of the spaghetti breaking. The reporter answered all of my questions with the diameter, because it's really interesting question. What is winning, mass, either critical curvature? Also, there were some questions considered to the wave. What happens with wave when we change parameters? However, I must say that I'm still totally disagree with respected reporter about that we can calculate this critical force as something constant over time. I think that there's a very difficult displacement of the curvature, but however, we're discussing reporter's work now. So I must say that in the report we have seen all these descriptions. During discussion, we have made a further deepening into this task. We are now understanding everything here, so I want to say thank you for your attention, and thanks for the reporter for a great presentation and great discussion. Thank you.
Reporter, when you say you bake the spaghetti, can you clarify exactly why baking spaghetti will make it easier to break?
Baking the spaghetti?
Yes.
Because it was change the structure of the atom in a microscopic view. It'll change the structure and the chemical ingredients of the spaghetti, and so that's why it'll make it easier to break.
Okay, thank you. Opponent, do you think that there will be any side effects from baking the spaghetti?
Well, I must say that for breaking spaghetti, I assume there is the same mechanism of difference like for example, wood. because if you are increasing temperature for a wood, the water is heated, it starts vaporizing, and it destroys some small microscopic structures in the wood, so it just makes a small slits inside it and small deformations.
So do you think he should have baked? Do you agree? Do you support him baking the spaghetti, or do you think he should have?
Well, I think
not baked?
that's a good way to change such parameters, critical curvature. It's very difficult to change it in the other way. However, maybe there will be some errors due to the existence of the slits, because they certainly change effects of the curing spaghetti in total.
Okay. Opponent, when you ask about the upward wave that travels along the length, can you suggest what exactly is happening inside the spaghetti that will
Once again?
What?
What's happening?
what exactly is happening inside the spaghetti when the wave travels through it that will cause a fracture there, and why there will be multiple fractures?
I think reporter has stated very well in his report that we have a bending wave that was occurring in spaghetti. Well, making my suggestions, I don't think that it's rather good, because we're discussing reporter's work now. And I just, making my questions, I just wanted to make a further discussion about the force which is acting on spaghetti, and the fact, can we or can't we consider it constant.
Okay, thank you. You also mentioned that one weakness was that he didn't consider the probability, right?
Yes.
So,
No, just as for me, I think the spaghetti is very difficult organic structure to consider, and for that reason, I
should he have experimentally considered it?
yes, I think he should.
Okay, reporter, you said that from dropping from 4 meters, the probability is 1/4, right?
Yes.
Yes. So, doesn't this contradict your theory?
No, because what happens is that we drop like a bag of spaghetti, so it has different collision angles. So under this condition, less than 1/4 break. So what we did in our experiments is that we control every parameter.
Okay. Opponent, you mentioned other forms of breaking. Is that correct? Other ways of breaking?
Yes, I mentioned that.
For example?
Well, for example, as for me, it would be interesting what happens if spaghetti just froze like this,
Yes. Okay.
but still it was reporter's review, so I was discussing only their type of break.
Thank you very much.